Here is section 14.2, reflections and glide reflections. So basically we're reflecting things across lines. So again, chapter 14 is all about transformations, how we change things. And in 14.1, we did translations, which means like we moved them. Right, that's movement, sliding things right, left, up, or down. And then we also did rotations, right? We practiced rotating things. Now in 14.2, we're going to reflect things. These are all different kinds of transformations that Chapter 14 is all about. Okay, so how do we do it? Reflections in a Cartesian coordinate system. So we're going to reflect things, kind of like a mirror reflects things. We have point A right here, which is 1, 4, over 1, up 4. And we're going to reflect it through the line y equals x. This diagonal line, we want to reflect it across that diagonal line. How do we do it? Well, reflections always move at 90 degrees towards, points always move at 90 degrees towards the reflection line. So to find the reflection image, how do we find a reflection image? Go straight at the line, straight to the line, let's say, to the reflection line at 90 degrees. That's what it means move straight, right? In other words, this dot, I'm not going to move like towards the line that way or that way. Those don't make a 90-degree angle. I'm going to move straight at it this way. See, that makes a 90-degree angle. So reflection images always go straight at the line, at the reflection. Dots always move straight at the reflection line at 90 degrees. And they go the same distance to the other side of the line. They go the same distance to the other side of the line. So how far is it here? This is one diagonal jump and then a half. See how that's only one and then a half of a square. So the first one's a whole diagonal square, and the second one's only half a square. So it's gone 1.5 diagonals, one whole diagonal and a half a diagonal to get to the line. So it'll go a half and 1, a half and 1 on the other side. Let me draw those a little better. Right there, that's a half and then 1. And so there it is. There's the point, and that's the coordinate. That's called that A prime, and that's at 4, 1. Over 4 up 1 from the origin, from the origin. So you see how we locate that point? You move straight at the reflection line, 90 degrees. That's what it means straight at a line at 90 degrees, and you go the same distance to the other side. That's how mirror reflections work, right? Imagine if you got a mirror, and you're standing at the mirror. You look at it with your eyes, and you see the reflection. It looks like you... Whoops, I'm drawing you kind of funny there. It looks like you are the same distance to the other side of the mirror. That's what it looks like. We know you're not really in the mirror, and you're not really on the other side of the mirror, but your image looks like it's the same distance to the other side. If somebody else is standing further back from the mirror and looks at the mirror, their image looks like it's further back, doesn't it? Or if you back up, it looks like your image backs up further away also. So that's how reflections work, don't they? Same distance, you go straight at the mirror, and you go the same distance to the other side. If you're closer to the mirror, it looks like your image scoots up closer to the mirror. And if you back up, your image backs up. That's how reflections work. Let's do B. Here's B. He's, again, 1.5. Boy, they didn't change it, did they? It's exactly the same. I think they'd be a little creative there. So that's 1.5 diagonal jumps. So it's going to be exactly the same thing, 1/2 and 1. 1/2 and 1 to find B prime. There's B prime, 0, -3. Okay, let's get to the homework. So here's how the homework's going to work. Here's the first one. We've got the point N right here, and we're going to reflect across the line y equals x. Now the line y equals x is the diagonal line going up right. So in other words, this line that goes right through the diagonal, that's the line y equals x. You might remember that from algebra. On that line, all the y coordinates, see the points? This point is over 1, up 1, over 2, up 2, over 3, up 3, etc. All the y values equal the x values. So that's the line where all the x and y values are equal. So that's the line y equals x, right? All these points like 3, 3, 2, 2, 1, 1, 0, 0, -1, -1, etc. The x and y values are all equal. So that's the line y equals x. So when they say the line y equals x, you know what it is. It's that diagonal line. All the points on that line, their y value and their x value are equal. Okay. So now what are we supposed to do about it? They want me to reflect this point in. Okay, so what do? We move straight at the line. So 1, I'm not making that very clean. 1, 2, 3.5, huh? This is 1, 2, 3, and then this is 1/2 right there. So 3.5 squares, diagonal squares, to get to the line, and then you go the same distance to the other side. So it'd be 1/2, 1, 2, 3. So this little jump here is 1/2, and 1, 2, 3. So there it is. Here is where the image, in prime we call it, it's the image. We'll just say the image of N. It's where if you're looking in a mirror, it's where you would see your image. Straight at the mirror, same distance to the other side. So what's the coordinates of that image point? Meaning from the origin. Like from the origin, how do you get to that point? 1, 2, 3, 4 back. 1, 2, 3 up. Back 4, up 3. Back 4, up 3. That's the coordinates. Right? What are the coordinates of the new point after the reflection? Back 4. From the origin, it's back 4, up 3. There's the image point. Okay, let's try another one. So this one wants us, we got the point G there, and they want us to reflect across the line x equals 4. What's the line x equals 4? Well, it's the line that goes right through the x-axis at 4. So we're going to reflect. How do we do it? Remember, we move straight at the reflection line. 1, 2, 3. So then we go 1, 2, 3 the other side. There it is. That's going to be the image of G. What's the coordinates of that point? 1, 1. Easy enough, right? Straight at the reflection line, same distance to the other side. That's what reflections do. Okay, let's try this one. Reflect across the line x equals 3. So here's the line x equals 3. You know what we do? We move straight at the line, same distance other side. Just 1 to the line, 1 to the other side. There it is. There's the image of P. What's the coordinates of that point? That's over 4, up 4, isn't it? Over 4, up 4 is the coordinates of the image of P there. You know, from the origin. 1, 2, 3, 4, 1, 2, 3, 4. Okay, let's try this one. Reflect across the line y equals -5. So what's that? What's the line y equals -5? It's this line right here. Because that hits this is the y-axis, notice, hits the y-axis at -5. So that line right there. So the reflection will move straight at that line, you know, at 90 degrees to that line. What is it? It's 2 to the line, so 2 to the other side. There it is. There's the image of U. It's going to be right there, straight at the line, same distance to the other side. What's the coordinates of that point, U? From the origin, it's back 1, 2, 3, down 1, 2, 3. Back 3, down 3. Coordinates of that point. There we go. Okay, now starting with number 5, we're going to start doing triangles. So we're going to reflect across the line x equals -4. Here's the line x equals -4 hitting the x-axis at -4. We're going to reflect all 3 of those points across that line. So let's take them one at a time. First with S. So where's S? Right here. Go straight at the line. That's 2. Same distance other side. There it is. There's the image of S. What's the coordinates of that? Back 6, up 3. That's the image of S. Okay, let's do the next one. T. So for T right here, straight at the line, same distance other side. 1 here, 1 here. Boom, there it is. There's the image of T. What's the coordinates of that point? Back 5, up 1. And now U, where are we going to find point U? Here's point U. So how far to the line for him? 1, 2, 3, 4, 5. 5 straight to the line at 90 degrees. So 5 to the other side. 1, 2, 3, 4, 5. Right there. There's the image of U. What's the coordinates of that? Looks like back 9, up 4. And now that we have those, we can actually draw the new triangle, which I think is helpful and interesting. Let's do that. Okay, so I'm going to connect these 3 points. Boom, boom, boom. See how that's a reflection of that triangle across that line? It looks like a mirror image, doesn't it? It looks like we reflected that triangle right across that reflection line. It's a mirror image. Let's try number 6. They want us to reflect across the line y equals -2. So that's this line right here. Hits the y-axis at -2. And so now we'll take the points one at a time again. We'll start with the first one. D. So where's D? Right here. 2, go straight at the line, 90 degrees, 2, and then so it's 2 to the line, 2 to the other side, boom, there's the new D, the image of D. What's the coordinates there? That's over 2, up 0, isn't it? Okay, next one, let's do E. Take E now. How far is it to the line? 1, 2, 3, 4, 5 to the line, so 1, 2, 3, 4, 5 to the other side. So there's E. Oh, and what's the coordinates of E? Looks like E is what? Over 2, up 3 on the coordinate system. And then finally we'll do F. So F goes straight at the line. 1, 2, 3. 1, 2, 3. There it is. There's the new F. What's the coordinates of F? Over 5, up 1 on that one. Okay, now let's connect up the new 3 points to make the reflection triangle. Look at that. It looks perfect, doesn't it? It looks just like that triangle's been reflected across this reflection line. It's a mirror image across that line. Number 7. Reflect across the line y equals x. So you remember what the line y equals x is. It goes right through the diagonal like that. So we're reflecting through that line. Let's do them one at a time. Point L first off. So remember, you go straight at the line, 1.5. So a half and 1. There it is. There's the image L. What's the coordinates of that? Looks like back 1, up 2. Now let's do M. We're going to need to go straight at the line, 90 degrees, right? Always, these are always at 90 degrees. 1, 2.5, right? And then half, 1, 2. So right there is the image M. What's the coordinates at that point? Looks like back 4, up 1, and then finally we'll do N. We're going to go straight at the line. Now careful, don't get thrown off by the side of the triangle. This line goes up right, so we're going to go up left. 1, 2, 3, 4. See how that was 4 diagonal boxes, and that's at 90 degrees to the reflection line. So 1, 2, 3, 4 to the other side. And that's N. That's the image of N. What's the coordinates of that point? Back 3, up 5, it looks like. Okay, now connect up those 3 for your image triangle. There it is. Look at that. That looks perfect, doesn't it? It looks like we reflected that triangle right through the mirror to the other side. It's a mirror image. Okay, one more, last one. Reflect across the line x equals 3. So here's the line x equals 3. Right there, hits the x-axis, right? The x-axis at 3. Now we're going to reflect each of these points one at a time. Let's start with R. Now R is right on the mirror. So what happens if you put your finger right on a mirror? It looks like the person in the mirror just put their finger right on the mirror on the other side of you. So the image of your finger is right at the mirror. It doesn't go anywhere. It stays right there, right? If we move to the line, there's nowhere to move. We're on the reflection line. So the new R is the same as the old R. So the coordinates on that are going to be 3, 1, isn't it? That's over 3, up 1. So that's the image point R. Let's now find S. So S goes straight at the reflection line. That's 1, 2, and then 1, 2 to the other side. There's the image S. And what's coordinates of that? Looks like 1, 1 for that one. Not making that very neat. 1, 1. And no, that's, 1, 1 for that one. The image S. And then finally, let's figure out the point T. Here's T. Let me change my color. Here's T, straight at the reflection line. 1, 2. Same distance other side. 1, 2. And so that's right there. And so the coordinates of that point T are what? 1, 3. 1, 3. Okay. So that's our new image point T. Let's connect up our 3 image points to find our image triangle. There it is. And it does. It looks just like a reflection of the triangle across the line x equals 3. There we go.